Thank you for watching this video. I'm going to explain the very basics of decision trees. A decision tree shows the sequence and the structure of a decision problem. They are extremely intuitive, even for beginners completely new to decision analysis. I'm going to create a very simple decision tree for a very basic yet not uncommon decision. Should I bring an umbrella with me today? A decision tree has three elements: decisions, uncertainties, and values or payoffs, which in DPL are called get pays. In the example, the decision is whether to bring the umbrella or leave it behind. The uncertainty is whether it's going to rain, and the payoff is happiness or a measure of satisfaction. I'll build this simple decision tree graphically in Syncopation's DPL Professional version. I'll start by adding a decision, which in DPL is represented as a yellow square. I will name the decision Bring Umbrella. Every decision has two or more alternatives, or possible actions to take. In this case, the alternatives are yes and no. DPL has already provided these alternatives by default. Notice that the decision node has two branches coming out of it, one for each of the alternatives. This particular decision node is asymmetric, meaning each alternative branch has its own attachment point and can be handled differently. Attachment points, or leaf nodes, are represented by blue triangles in DPL. Now for the uncertainty. Uncertainties take the form of discrete chance nodes in DPL and are represented by a light green circle. I'm going to drop the chance node on one of the decision endpoints. I'll rename the chance node to be rain. Uncertainties have outcomes, or possible things that can happen. When a chance node is discrete, it means there are a finite number of outcomes. In this example, our uncertainty has two possible outcomes. Yes, it will rain, or no, it won't. Typically, probabilities are specified for each outcome. Let's assume I happened to catch the weather report this morning and heard that there is a 60% chance of rain today. So I will enter a probability of 0.6 for the yes outcome and 0.4 for the no outcome. We'll add another instance of the same rain chance node to the second decision branch. Our payoff, or level of happiness, will be different for each of the four scenarios in the tree. Now for the last element of a decision tree, payoffs. In DPL, we call these get pays. To keep things simple, I'll enter each of the four get pay values directly in the tree. In a more complicated model, I might use a value node containing a formula. Let's say a satisfaction level of 1 is contentment, and any values below this are negative feelings. The lower the number, the worse you feel. Our first scenario is that we bring the umbrella, and good thing we did, because it does in fact rain. I'd be content with this, so I'll enter a get pay value of 1 for this outcome. The second scenario is that we bring the umbrella, but it doesn't rain. Slightly annoying, right? We lug the umbrella around all day, but never need to use it. The satisfaction level, or lack thereof, may vary slightly by individual circumstances. Maybe you have an extra heavy umbrella or a long distance to walk with it. For me, I'll enter a -2. Now let's proceed to the second alternative. We don't bring the umbrella and it rains. Now this is the pits. I'm entering a value of -3 here. And last of all, we decide to leave the umbrella behind and it doesn't rain. We are content again, so I'll enter a 1. Our decision tree is now complete. We can run a decision analysis and produce an output, a results tree, called a policy tree, that will indicate the optimal decision alternative. DPL does this by calculating the rollback expected value at each chance node in the tree and choosing the alternative with the highest value at each decision node. As you can see, DPL shows that the optimal decision alternative, given the probability of rain and your level of satisfaction with the various possible scenarios, is to bring the umbrella. And now you know what a decision tree is.